Hello there, let's look at another Decode problem. This is problem 91. Decode which you have intercepted a secret message encoded as a string of numbers. The message is decoded via the following mapping: 1 to A, 2 to B, 25 to Y, 26 to Z. However, while decoding the message, you realize there are many different ways you can decode the message because some codes are contained in other codes. 2 and 5 versus 25. For example, 11106 can be decoded into AAJF with the grouping 1126, KJF with the grouping 1110.6. The grouping 11106 is invalid because 06 is not a valid code. Only 6 is valid. No, there may be strings that are impossible to decode. Given a string as containing only digits, return the number of ways to decode it. If the entire string cannot be decoded in any valid way, return 0. The test cases are generated so that the answer fit in a 32-bit integer. Alright, so I think I got the... Alright, so let me read the problem to see if I have any question. So we have a string S, and we would like to return the number of ways to decode it. And the way we decode it is from 1 into A, 2 to B, up until 25 to Y. So let's make it capital. And 26 pointing to Z. So let's look at the example 0 there. We have 11,111,06. So there are a number of ways we could split it up. It could be 1, 1, 10, 6. Let me write it down in a clearer way. We have 11106. So it could be split into 1, 1, 10, 6. It could also be 11, 10, 6. It could also be 1, 11, 06 is invalid. Okay, so that's invalid. Let's look at example 1 there. We are given 12. So this could be split up into 1, 2, or 12. Alright. Second example, we have 2, 2, 6. So this could be split out into 2, 2, 6, or 22, 6, or 2, 26. So there are 3 ways. Example 3, we have 06. Now there is no way we could do this because we don't have a mapping with keys that start with 0. think I got the question now. I would like to clarify a few things. First of all, what is the length of S? So here we are given that length of S is between 1 to 100. And I just assume that all of the digits are valid. And it may contain leading zero, but it is fine because we are gonna handle that. So what we're gonna do is that I think let's look at one of the example, simple example, like example 1, so that we could have some idea on how to solve that. I think I understand the problem now, and can think of let me think about possible approaches for this problem. I would like to explore example 1 there because that looks so simple to me. So when we have 12, you could split up into 1, 2, or we could combine them into 12. So how do we know if we could split up into 1 and 2? So I think at any stage we could take up 1 or 2 string at a time. But if we want to take 2 string, we need to make sure that the number is less than 26. Okay, so I think we could do this step-by-step basis. So if we are given 1, 1, 2, first of all we start with nothing, and then we could take 1. When we see only the first character, we could only take it. So there's only one way. When we are given 2, now there are we found another way to do this. So 2, it could also be 12. Now let's look at example 2. We have 2, 2, 6. We start with nothing. Now we take 2. And then we see another 2. So let's take them. And then now we see 6. Now 6 could be, for the first step, we could split it up into we could combine them into empty 2 to 6 or empty 2 26. And then for the first one we could just do it by itself, so 22 and 6. So at any stage, we could combine new. So we could either create or append. So we got two choices. We could append or we could create a new one. Now let's look at the third example. We have 06. 06, we cannot do anything because it starts with 0. So when I look at this, so we got two choices. We could either create a new one or we could just append it as long as it is valid. So the way we are going to do this is that let me go back to the earlier one. Okay, so example 0, we have 11106. So we could do 1, then 1, or we could combine them, and then the 10, it has to be 10 and then 6. So I think there is a recurrence here that I observed. So first of all, if there is the string is empty, then there is 0 ways. If there is a 1, then there is 1 way. If there is 2, I need to create a condition. If the character is not 0, F2 is, how many ways are there to get F2? It could be F1. So it is F2, could be 1 if sorry, I think this should be F1. F1 times, okay, so this should be F1 if C is not equals to 0 plus 1 if F1 if C is between So let me make it C1 and C2. Okay, let me redo this thing. Okay, so f0 is 0. So every f, we could define f as number of create plus number of extend, or let's say number of way to transform. Okay, so f0 we cannot create with zero string, with empty string, so there is 0 ways to create and 0 ways to transform. F1 would be how many ways to create, how many ways to decode it if there is only one character. So it depends if this one, if C of 1 is not equals to 0, otherwise it's 0. F2 so for F2, if you want to create, how many ways to create a new one? If how many ways to create a new one? So that would be meaning that the F1 has to be positive. So this would be F1 times 1 or 0 if C2 is not 0 else. And then the number of ways to transform. So if we transform it, then it means that we take up the first character and then we combine with the current character. So how many ways are there? This would be F0. Is it F0? Anyway, this is just two characters, so we just check whether. So this would be 1, either 1 or 0. So the number of ways to transform is 1 if C1 is in 1 or 2. Actually, it is much more restricted. So it has to be a 2 character. Well, then it would be between 10 to 26. Is it? Yeah. So C12 is between 10 and 26. else it is 0. And then F3, the number to create is the number of ways to create a new one is F2 times the syntec 1 0 if C3 is not 0 else. F2 yep. And then the number of way to transform, now this would be F of 1 times the number of way to transform it. So if 10 C2 3 26 0 else, and so on and so forth. Yeah, so I think this would be the recurrence function, such that we will end up with Fn equals Fn minus 1 times condition whether Cn is not equals to 0 plus f of n minus 2 times condition that the character of the previous one until the current one is between 10 and 26. I think this sounds reasonable. Let me test it with our example there. Does this sound reasonable to you? So let me test it with our example. So let's start with example 0. Have 11106. So if n is 0, and okay, let me just write down everything. So n is 0, then we have 0 ways. N is 1, we have 1 way, which is just 1. If n is 2, we have n minus 1. Okay, F2 is still a base case, so F2 is F1 yep, so it would be 1 plus, is it between that? Yep, so 2 So if there are two ways, it is 1, 1 or 1, 1. If n is 3, then now this is where it starts to get interesting. If we take n minus 1, yeah. Now f3, we could do with f2 append with what is it? So it's 1 and 2, and then we append with 1, or we could also do with f2, I mean f1, because 3 minus 2, we got f1. And then we combine it there. So yeah, so 2 plus 1. So we got 3. Yep, so far we have seen 3 ways to do this. Now if n is 4, we could take f3 append by 0. Now we cannot do this, but we could do, what we could do is f2 and then append the 10 there. So how many ways are there? There is only 2 ways. Now we come across the 6. We could do f5 comma 6. That's valid. Or we could do cf3 comma 06. Now this is not valid. So how many ways are there? It is the same as the number of ways for f5. Oh, sorry, f4. So 2 ways. Yep. So we end up with only 2 ways to do it. Is it correct? That is what we got. And yep, that is the answer. Now let's look at example 1. We have 1, 2, and so n0, we have 0. Actually, let's give it to 1 and 2 directly. So 1, yep, we could do it 1. So there are 1 way, and n is 2. N is 2, we could the current character can stand by itself, so f1 comma 2, and then we could also do all by itself, which is 12. So there are 2 ways, which is correct. Example 2, we have 2 to 6, and f, and the n is 1. There is only itself, so there is 1 way. 2, we could take the previous one, so f1 comma 2, so this is possible. Or we could also combine them, which give us 22, also valid. So there are 2 ways, n equals 3. Now we could take the previous one, f2, and then 6 can stand by itself, or we could take f1 and 26, also valid. So f1 plus f2, which is 3, and that is correct. Example 3, we have O6. Now NL. N is 1. 0 cannot stand by itself, so F is 0. Q, now we could take F1. F1 is 0, so can stand by itself, but it is actually 0. We could take O6, which is not valid, so whole thing would be 0. Alright, I'd like to start implementing this unless you'd like me to explore further optimization. Building as a proceed with coding. I suppose the answer is yes. So the way I'm gonna do this is that I'm going to do it iteratively. So let's see how we're gonna do this. Okay, I got an idea. So I will use previous one and previous two. First of all, I'm gonna create a check function. So the check here will determine whether the string is valid or not. Define check of s. Let's just call it valid. So define valid of s. Return s is between 1 to 9. Or it is between 10 actually it could just be between 1 to 26, right? Yeah, I think so. So we just return if it is between 1 and 26. Okay. And then I'm gonna look through everything. So the base case would be okay, let's see. If there are only two characters, that is the base case. So if okay, let's handle the base case. P2 equals value of the character, so s of 0 if length of s is just 1, then we return p2. Now P1 is P2 times value of S1 plus value of S to the first two characters. Now if length, actually we could just go directly to the for loop. For I in range length of S, actually we need to start from the say third one. So 2 comma length of S. And then what we're gonna do is P2 comma P1. P2 will stop P1, and then P1 will be say P P1 times value of S of I plus P2 times value of S I minus 1 up to I plus 1. At the end we return P1. Okay. Let me quickly walk through the code to make sure I haven't missed anything. So first of all, I'm gonna create a valid function to check whether I have a valid number or not, valid key or not. And then P2 would be the base case where there is only one character. So I need to check whether the character itself is valid. So we just call P2 equals valid of S0. If length is 1, then that is the answer that we want. P1 would be the first two characters. So it means that if P2 is valid, then we need to check whether the character of S1 can stand alone. If yes, then we add it into our count of P1. And also we check whether we should combine it together. So that will be the S from the beginning to the first two characters. And then the main part is here. We create a for loop to look through all the characters from the third one until the last. So what we do is P2 will now store to P1. P1 will be updated to, depending on P1 of the SI is valid, meaning that it can stand alone. They multiply it with the P1, and then we add it with the P2, given that P2 multiplied by the I minus 1 to I plus 1. Okay, I think this should be it. So if we look back at our test cases there, we have N and F. So F2, F1 would be the P2. So if it is valid as in example 0 to example 2, there will be 1. Otherwise, in example 3, we see that f1 is actually 0. And then the p2 would be the f2 right there. So if s0, if p2 is valid, then we multiply it whether the current one is valid or not. Example 3, we got 0 there because the first character cannot stand alone. For the other, it will be 2, or maybe it could be 1 if it cannot stand by itself, as in like a 10. Yep. So the for loop itself, p2 will store p1, and this is actually for the memory efficiency. I could just build an array for that, but this is like a minor optimization so that we could achieve O(n) time and O1 space. So P1 would then be P1 times value of the standalone character plus P2 of the previous 2 character. Okay, so I think this should work. Let me quickly put our solution into the code to see if it works or not. So we define valid as return if it is between 1 to 26. P2 is valid of s of 0 if length of s is 1, then return P2. Otherwise, P1 would be P2 times valid of s of 1 plus valid of s of the first 2 characters. Now here comes the main part for loop. Actually, do I need the P1 defined before? Yeah, I think I don't need it. So actually I can do P1 here. P2 is just I just initialize to none, and it doesn't matter that much. For I in range of 1 to length of s, P2, P1, P2 is just a dummy for the current. Then this would be, oh no, I mean the P2 initialize. Right, so I cannot do that. Sorry for the confusion. in range of 2, length of s, then this would be p2 comma p1 equal p1 times value of s of I plus p2 times value of the last two. The last two characters, so I plus 1. And then here we could just return p1. Let's try to run this. No, we got it wrong. So we got it wrong. Print. Okay, let's try to print out everything. P1, P2. P2, P1. And here we print out the P1. Okay. One, two, one. Why is that? So change it to integer here. I think it doesn't matter. Yep, still wrong. So let's see. It should be 1, 2, 3. So what went wrong here is that, let's see. P1 is P1 1 times value. Okay, so okay, let's try to print the result here. Value print s comma value return integer of value. True, 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 true is true, 6 is false. Alright, so I didn't know it. So 6 is not less than 26. So what we need to check instead is that s is less than or equals to 9, or it has to be larger than 10. S 26. So let's see this. And now we got the correct answer. So we comment out all the printing debugging line and then run it again. Yep, we got it right. So let's try to submit this. Hopefully we got it correct. Wrong answer. 27. How many ways are there? So we could do 2 and 7 or 27. Okay, 27 is not possible. Alright, so let's check this. And then let's turn on the debugging. So 2 is true, 7 is true, 27 is also true. How is that? I think I need to check the length here. Yeah, okay, I got it. It is this, and length of S is equals 1, or it could be this, but the length has to be 2. Yep, now we got it right. So let's try to submit this. Okay, we got it right. I think there's a bit of luck that I end up with 1 millisecond solution. Let's try again. Yeah, I think more or less it's this kind of solution. Oh, but I removed that in check. I think I don't need that. Funny. Okay, how about this? Okay, let's look at some solution. Although it says 1 millisecond. And then everyone is doing more or less the same thing. Okay, I think I could have improved on the checking step here. I think it's more efficient and cleaner if I just turn the whole thing into an integer after I make sure that the first character is not a 0. But yeah, I think solution That's good. Okay, I think we will stop here. Thank you, everyone.